Welcome to our session on evaluating the dangers and safety measures associated with artificial intelligence. In this lesson, we will uncover how organizations identify, measure, and handle the unique uncertainties that artificial intelligence brings into the corporate environment. You will learn how to integrate these modern evaluations into traditional corporate safety procedures, distinguish between strategic risk thresholds and tactical risk boundaries, choose the right response strategies, and build effective correction plans. The real-world utility of this knowledge is massive. In your daily professional life, mastering this allows you to confidently advise your executive board on whether adopting a new smart automation tool is a safe bet or a dangerous liability. You will be able to look at a proposed corporate machine learning project, systematically isolate the specific dangers it poses to your data or reputation, and dictate exactly what technical or procedural safety nets must be built before a single line of code is deployed. Let us start with the core philosophy of evaluating artificial intelligence risks. You must never treat intelligent systems as an isolated island. Evaluating the dangers of smart algorithms has to be smoothly woven into the existing risk evaluation processes that a company already uses. Think of it like adding a new, highly advanced electrical circuit to a house. You do not create a separate electrical grid just for that one room. Instead, you connect it to the main breaker box, ensuring the whole house safety mechanisms still apply. These evaluations need to happen constantly, especially whenever a change is made to the software. A great place to begin is by using your company standard definitions for assessing how likely a bad event is to happen and how severe the damage would be. However, intelligent algorithms have unique quirks. You must meticulously document these special characteristics. If your company current safety playbook lacks chapters on these modern tech attributes, you have to rewrite the playbook. When looking at the specific considerations for assessing these systems, there are 4 major areas to focus on. First, you need solid methods and metrics. This means you must write down exactly how you will measure danger and reliability. Do not just take the word of the programmers who built the tool. You must bring in outside, unbiased experts to double-check the developer's claims. Second, you have to evaluate trustworthy characteristics. This involves checking if the tool behaves ethically, treats all users fairly without prejudice, and can actually explain how it made a decision. It also means looking at physical safety, protecting sensitive corporate intellectual property, respecting basic human rights, and even measuring the environmental impact of running massive computer servers. Third, you need tracking mechanisms. You must proactively hunt for dangers that are happening right now, dangers you did not expect, and dangers that are just starting to form on the horizon. Finally, you must gather feedback. Your measurements must include a way for end users and stakeholders to report how well the system is actually working in practice. Next, we need to understand 2 concepts that often confuse people. These are risk appetite and risk tolerance. Let us break them down. Risk appetite is the total amount of uncertainty a company is intentionally willing to take on to reach its big strategic goals. This is a deliberate, high-level choice made by the absolute top leaders of the enterprise. On the other hand, risk tolerance is tactical. It is the acceptable wiggle room or deviation from that main appetite. It represents the exact amount of pain, usually measured in dollars, that a specific department can absorb before it ruins the company grand plans. To use an analogy, imagine a commercial airline. The board of directors sets the risk appetite by deciding they are willing to fly through areas with a moderate chance of bad weather to save fuel and offer cheaper tickets. That is the broad strategic vision. The risk tolerance is set by the individual pilot, who decides that the aircraft can handle a maximum crosswind of precisely 40 miles per hour during landing. If the wind hits 41, they abort the landing. Appetite is the big picture at the enterprise level, while tolerance is the precise boundary at the project or departmental level. Both the people creating intelligent tools and the people buying them must clearly define these boundaries based on business goals and strict laws. Because this technology is so new and unpredictable, getting involved usually requires a company to have a fundamentally higher appetite and tolerance for uncertainty. For instance, a hospital deploying a robotic surgery assistant must have carefully calculated an incredibly specific tolerance for error because the ultimate accountability for patient harm rests entirely on their shoulders. Once you know your boundaries, you have to respond to the dangers you find. The goal here is risk treatment, which simply means taking action to push the danger down to an acceptable level. What remains after you take action is called residual risk. Think of residual risk as the leftover danger. You want that leftover danger to sit comfortably within your defined tolerance. There are 4 primary ways to handle these threats. First is avoidance. This means you simply walk away. If a bank decides the legal danger of using an automated loan approval system is too high, they completely abandon the project. Second is mitigation. This is where you reduce the chances of something bad happening or cushion the blow if it does by adding controls. For example, an e-commerce site uses a smart recommendation engine but employs human reviewers to randomly check the suggestions, putting a safety net in place. Third is sharing or transferring. Sharing spreads the pain among business partners, while transferring pushes it onto a third party entirely. Imagine a shipping company outsourcing its route optimization software to a specialized vendor, signing a contract that makes the vendor financially responsible if the software causes delivery delays. Fourth is acceptance. Here, leadership looks at the threat, realizes they cannot avoid or fix it efficiently, and decides to move forward anyway because the reward is worth it. A retail brand might launch an automated fashion consultant app knowing it might occasionally give clashing clothing advice, but they accept this minor brand embarrassment for the sake of innovation. Crucially, if you accept a threat, you must intensely monitor it to ensure it does not grow out of control. You cannot fix every single problem. It is too expensive and time-consuming. You must prioritize your efforts based on strict criteria, tackling the most severe threats first in alignment with your corporate policy. Finally, we reach remediation plans, which are simply the step-by-step repair guides for fixing unacceptable dangers. Because intelligent software often weaves through many different departments, like human resources, finance, and marketing, it is absolutely critical to establish clear ownership. Someone specific has to be held accountable for the repair. For any threat that bursts past your tolerance boundary, you must write a repair plan with concrete steps and expected conclusion dates. This plan is handed to a risk owner. The risk owner is the designated champion who must execute the fix, work with the risk management department to secure resources, and report progress to upper management. Sometimes, fixing a complex algorithmic flaw takes a significant amount of time. If that repair timeline is too long, you must use compensating controls. A compensating control is a temporary band-aid that keeps you safe while the permanent surgery is happening. Let us say an automated corporate drafting tool is found to occasionally leak internal data, but the software patch will take 6 months to build. Instead of turning it off, a compensating control might involve a staggered rollout only to a small group of low-risk users. Other strategies include adopting strict temporary policies, conducting emergency end-user training, or installing temporary technical security firewalls. These repair plans require strict babysitting. An entirely independent department within the company must track the risk owner progress through regular status reporting. And when the risk owner finally declares the repair complete, independent auditors must be brought in to verify that the danger is truly neutralized. Let us recap our journey today. We established that smart technology evaluations must be baked into your existing corporate safety protocols. We explored the difference between the strategic vision of risk appetite and the tactical boundaries of risk tolerance. We reviewed the 4 primary responses to danger, which are avoiding, mitigating, transferring, and accepting. Lastly, we highlighted the critical need for designated risk owners, temporary safety nets called compensating controls, and independent verification of all repair work. All the vital topics and technical distinctions from this session are covered in the multiple choice questions on RooCloud.com. You should ideally solve the chapter-wise questions right now to cement your understanding before we move on to the next session. Great job today, and keep up the excellent work.